Hi there, in this video I'm going to make the flywheel for the Jerry Howell V-twin. Now when I assembled the crankshaft I didn't put a spacer at the other side of this bearing, sort of on the inside, because I didn't really know what it was for. But now I do realise what it was for, because the idea is that when you put the flywheel on here you don't want it to put any undue pressure on this inside race, so it'll put pressure on the actual ball race incorrectly. So what I've decided to do, I'm going to modify the flywheel. So I'm going to put a little flange to butt up against that. That's the plan. I'll show you the drawing I've adjusted. There's nothing like making life a bit more complicated. This is a rough sort of outline of the original drawing really, and this shows a 60-degree taper here, which is going to take a collet. And I've calculated that the inside diameter here when it breaks through will be 0.64 of an inch, which is a bit confusing really, because I would have thought that it would have butted up against this inside bit here of the bearing, this bit. 0.640 is just on the outside of that. And even more strangely enough, the outside diameter of this area here that's butting up against this bearing is going to be 1.025 of an inch, which 1.255 I've got here, which is this, which will sort of encroach on the outside of the bearing. Doesn't make sense to me at all. So I don't understand the original drawing, but anyway, I'm going to modify it. I've got to modify it anyway because I've not got this spacer in place here. So what I'm going to do is I'm going to put a little bit of a flange on here. And when I cut this taper, I'm not going to break through, I'm going to hold off. And this little flange here, the inside diameter is going to be 0.438 of an inch. So it's just a little bit wider than this. And the outside diameter is going to be 0.496, which is just less than the inside of this bearing. So hopefully this area here will butt up against this area here on the crankshaft. I hope it'll work out, but I guess we'll see as we progress. Well, the drawing suggests using stainless steel for the flywheel, but I've got this piece of cast iron and I think it'll buff up okay. So that's the face done. I've just centre drilled and now I'm going to go through with this 6mm drill bit. Once I've done that, I'll then drill 27/64 and then ream to 7/16. But I'll do those bits off camera. So now it's a matter of making the little boss here. So I'm going to make it 50 thou deep, and I'm going to cut in around about 10 thou increments, and I'm going to get up to around about that point, and once I've done that I'm then going to nibble away at it to get it to the exact dimension. Okay, so that's the boss roughly cut. So it's just a matter of nibbling away at it until I get it down to a dimension of round about, well, just under ½ an inch. .494, that'll do. And now I need to get the outside diameter down to around about 4 inches. I'm not sure whether this is going to go to plan, but there's a requirement to cut a recess out there 0.4 of an inch deep, and I think what I'm going to try and do is use this parting tool to define the edges, and then use another tool to cut it out. Probably not a good idea. So I think what I'll do is I'll do that work on the rotary table on the mill. So what I need to do now is to switch the part round and get this dimension down and face it off. But I'll do all that off camera. Well, here I'm cutting a recess, and it's going to be 0.175 of an inch deep, and the diameter doesn't really matter. I'm just cutting it bigger than what I need it to be. All this area will be removed later on the mill. Okay, so I've turned the compound slide 6 degrees, and I've calculated that I need to take a cut for a depth of, from this face here, a depth of 20 millimeters, and that should leave around about 150 thou at this far end. And I need to continue cutting, probably in about 10 thou increments, until I get to a diameter of this front end to be equal to 0.840 of an inch. seems to have turned out perfectly. Happy with that. So before I start machining that on the mill, what I'm going to do is I'm going to make the flywheel collet while I've got the compound slide set to 6 degrees. That's what I'll be making on the lathe. Well, the drawing suggests using mild steel for the collet, but I found this piece of leaded steel, which I think, well, it's certainly nice to machine and it probably work well as a collet. And I've already drilled and reamed it, faced it as well, and I've defined this top edge here with a parting tool. So the idea is, with the compound slide set at 6 degrees, I start cutting, the lathe will be running in reverse, and I keep on cutting in about 10th increments until I just get up to that edge, and when I get up to that edge I know I've completed the cut. I think that's just about got it. I think that's looking pretty good, and there is a slight gap in there allowing the taper to tighten up, so hopefully the job's a good one. Well, the collet's worked out okay, fairly straightforward really. So the idea will be that the flywheel will go on there, so this boss going onto the crankshaft like that, and then the collet like that bolted on. Looking good. Well, I think this is going to be a long process. I've got to get rid of 0.4 of an inch of material in depth. So what I'm going to do is I'm going to go down with this 2-flute end mill first of all, go round, and then hopefully I'll be able to sort of machine it out. Blimey, this is going to take forever. I've only gone down 0.2 of an inch. I'll get back to you once I've got rid of most of the material. Blimey, there was a lot of plunge cutting going on there with this 2-flute end mill 13mm. So that's that edge defined, not finished off, and now I need to define the inside edge. bit of vibration I need to sort out. But anyway, I'll carry on like this, and then I'll get back to you once I've completed the circle. And now I'm just going to tidy up the edges with this 4-flute end mill. So this is the other side of the flywheel, and I've sort of learnt that it's a bit easier when you're doing these downward cuts, these plunge cuts, just to maybe cut half the width of the actual cutter. Seems to go a lot easier. Well, nobody wants a wobbly wheel, so what I've done is I've made this mandrel very similar in size to the crankshaft, and what I'll do is I'll put the flywheel on it and check various sort of like surfaces. Well, measuring and run out on the outside edge, you'd expect this to be perfect, because this was machined on the lathe when I machined the inside where the collet goes. However, it is very slightly out. About a thou. Nothing visibly obvious, so I'm happy with that. But it's slightly different result on the inside edges, where these have been machined with the rotary table. And I get a similar result on the other inside edge. So what I'm going to do is I'm just going to machine these edges using the lathe and just tidy them up. Now I need to put a little chamfer on the inner edge here. I'm going to use this radius tool because I can't get in with anything else. So I'm using the compound slide at 45 degrees. But I'll cut it off camera because it's a little bit tight. Well, while it was on the lathe, I thought I would buff it up with some wet and dry, going through the grits, 400, 800, 1000, 1200, and I always tend to use a little bit of Yorkshire grit as well. That's for wood turning, but I find it works well on metal as well. I need to just tidy up the other side at some point, but I'll do that off camera. Well, this flywheel seemed to take ages. I'm really glad I didn't try and make it in stainless steel. I'd have been machining it forever. But anyway, I've managed to get quite a nice finish on it now, and I've machined the inside as well. It's pretty much out of sight anyway, and I've decided not to drill the holes to hold the pulley for the fans, because I think I'm going to leave the fans until later, if at all. I want to get this little engine up and running as soon as possible. And I've just made a little brass nut. I'm quite happy with that. It's quite tidy. And what I've also been doing is trying to run in the pistons and the piston rings within the cylinders. I'll show you footage on that. So I've decided to have a go at running these pistons in the cylinders, and I've put the rings on, and what I'm going to use is some of this graphogen paste, which somebody suggested last time I made an engine, and it seems to work really well for running in. So I'm going to smear some on the piston. I'm going to fit the cylinder and repeat the same process on the other cylinder, and then I'll try and run them in. Well, that's what the graphogen paste looks like, and I believe that they use this paste when they build Rolls-Royce engines. So if it's good enough for Rolls-Royces, it's good enough for this little engine. So to help run in the pistons and the piston rings inside the cylinders, I've put this piece of hose pipe on the lathe. Put the lathe in reverse and attach the hose pipe to the engine. Quite a bit of suction there. Ow! Wow! So I'll let that run for a while and see what the results like. What I've also done is just put a piece of, I think it's Perspex on the bottom, and sealed it. So I think we're getting there, and I think the next video I'm going to be looking at valve timing. I think get the valve case sorted out, or the gear case. But anyway, I hope you enjoyed the video, and I hope to see you later.